Welcome to my channel once again. Today, the subject we are going to discuss is on the gravito mechanics of relatively moving bodies. You may be thinking, yeah, actually, uh, this is more or less like Einstein's on electrodynamics of moving bodies, right? True, that's true. Because um, in the last video, I have explained that there is a quantum domain, there is a relative domain. These two are basically different. That's what I concluded, right? Here, if you take, let's say, this is 10 squared, I told you, 10 raised to 4, 10 raised to 6, the whole thing. And then we took one more 10 squared here, making the whole thing 10 raised to 8. That's what I told you last time. Same thing for relative world. Relative world. Here it was c squared, c cubed, and one more c. The whole line, this thing is basically c4. This is the famous. If you take three times this is the famous electromagnetic radiation, right? This is I called it gravito photon radiation, right? So, and also we have this Gauss law uh, for gravity. Uh, G dV uh, 4 pi G M something to that effect, right? And since we compare this to basically Coulomb's law for electricity, which is the electrical flux is equal to 1 by 4 pi r squared um, q1 q2 by epsilon naught. I tried to compare this with this and get this g in terms of what do you call 4 pi 4 pi r squared. I wanted to make both of them look alike. So what I did was I tried to convert g, which is 6.67 to 10 raised to minus 11, into 1 by 4 pi into something, right? this something which you can do just simply by dividing 6.67 with 4 pi, then whatever the number you get, if you multiply 4 pi with that number, you'll get 6.67, right? So this number turned out to be 119 into 10 raised to 7. See, if you work this out, it's approximately equal to 6.68 rather. So I told you that we can actually write, let be there, let us write it here so that we can, here g we have converted into 1 by 4 pi, 1 by 4 pi. This thing I called it a different, what do you call, constant. That constant, I said, this is in Greek letters, this is pronounced xi, xi in Greek, which is equivalent to x. I think, I'm not sure if x is xi, I don't know. But the xi, this is called xi. So this whole thing I called xi. So instead of having g, you can as well write this term. In which case, how will both equations look alike? Look, let's um, basically, my intention was to make the law of gravitation, Newton's law of gravitation, look like Coulomb's law. Newton's law of gravitation is the gravitational potential is equal to gmm by gravitational force rather, that is g, gmm by r square. Whereas Coulomb's law for electricity. What is Coulomb's law? Electrical force, electrical, I would rather say force, gravitational force, electrical, is equal to 1 by 4 pi epsilon naught into Q1, Q2 by R square. Right? So, if I change this, substitute G for what value we arrived at, 1 by 4 pi Z naught, which where Z naught is equal to 119 into 10 raised to 7, not minus. You see, if you don't get confused here with the mu naught is 4 pi into 10 raised to minus 7. Here, this xi naught is 119 into 10 raised to 7. If you call this xi naught, then this will be 4 pi xi naught into mm g r square. Now, do you see the similarity here? I have made Newton's law of gravitation look similar to Coulomb's law of electricity. So, the only difference is here it is mass, here this is charge, right? That's the only difference. Otherwise, this is 1 by 4 pi something not. 4 pi r squared rather. We should basically convert this into 1 by 4 pi r squared rather mm by uh, z naught. This is 1 by 4. This also we can write it as 1 by 4 pi r squared into q1 q2 by epsilon. So what I am doing is I want to make both terms look exactly same. 1 by 4 pi r squared, 1 by 4 pi r squared. So what does it mean? First we took with the circle we started, then we had this surface area of 4 pi r squared, this was pi r squared, this was 4 pi r squared, meaning the surface area of the sphere. 4 pi r squared here is equal to surface area of sphere, right? Even here it will be same. 4 pi r squared is equal to surface area of sphere. This is exactly what I wanted. So what all I mean here is these two laws are exactly same. They're equal. And I told you, so that is why we have two different worlds. One is quantum world, quantum domain. The other is the um, relative domain, right? One is quantum domain, the other is relative domain. So, but but here it is 10 square, here it is c. So 10 square is not c, c is in that dimension, which is basically the fourth dimension of quantum world. This is the first dimension. It became first dimension. So these two words are domains are entirely different. Now, now the next we'll go to Maxwell's equations. Maxwell's equations are for electromagnetic radiation, radiation, okay? Or you can say classical electromagnetic uh, uh, electromagnetism. You can say electromagnetism. You can say here we should have what do you call not relative. We will say this should be rather this should be rather gravito. That's what I call it. Photonic radiation. So, what are the laws? Since we have concluded that these two are not equal, this is quantum domain, this is relative domain, they are not equal. The fourth dimension of quantum domain is the first dimension of relative domain. So, though this first domain is common for both, this is common for both, they are different. So for electromagnetic radiation, what Maxwell's laws we have? First one is Gauss law. What is Gauss law? Gauss law says, so electrical force is equal to the electrical flux, rather, we say QE, let's say, is equal to rho by epsilon naught, right? Second law says, sorry, sorry, no, 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 the divergence, I got carried away with the forces. Uh, the divergence of E is equal to rho by epsilon naught. Divergence of uh, magnetic field is zero, right? Third, he says the curl of electric field is equal to minus rho b by rho t, partial differentiation. Fourth was the curl of magnetic field. That was given by that was fourth field was given by mu naught into J, current density, plus epsilon naught into dou E by dou T, right? This was a fourth equation. So similarly, first one for gravitopotanic radiation will be like Gauss law for gravitation. We all the way we had this Gauss law for gravitation, but we never used to pay attention to this as part of this Maxwell's equations, because we considered only for electricity. Gauss law for electricity only we considered as part of Maxwell's equations. We never considered gravitational law for gravitation. So, which is similar as uh, mass by rather that Gauss law for gravitation is the electrical flux is proportional to mass by distance square, right? It depends on this thing, but rather you can as well say uh, um, the gravitational flux is proportional to the mass enclosed inside. You can as well say 4 pi square, because this double uh, the surface integral, you divide mass by this volume, then you get the basically flux. That was a first law, which can be as well be expressed as rho by no, it can be expressed as rho by xi naught instead of the epsilon naught. We have xi naught because xi naught. What is xi naught? Xi naught um, is equal to 119 into 10 raised to 7. This is a xi naught. So we can have Gauss law for gravitation can be expressed as rho by xi naught. And second one, the sorry, I am a little confused with the laws and log and this. You can as well say this is basically this will be the law should be the um, grad and divergence of G, let's say. Divergence of G would be rho by uh, um, what Xenon. The second law would be, this will be, let us say, if L represents light, then the divergence of light is equal to 0 here. 3. The curl of G is equal to minus dou L by dou T. Fourth one will be the curl of L is equal to, here we had mu naught, here we had mu naught. In place of mu naught we will have xi naught into uh, the what do you call gravitational this thing density, gravitational density, that let's say 3D, and epsilon naught will be lambda naught, let's say, into dou L by dou T, right? Psi naught into gravitational density plus lambda naught into dou L by dou T. Now, the big question is, we know that the psi naught is 119 over 5, sorry, 119 into 10 raised to 7 psi naught, but what we don't know is the lambda naught. The one I use in place of lambda naught, that we don't know. Let us uh, let us see. We have computed G as 1 by 119 into 4 pi into 10 raised to 7. This we can as well write it as xi naught. This was what we derived. So there should be a similar what do you call constant for luminosity or the electrophotoradiation. Using electrophotoradiation, for photonic radiation there should be a constant. What is the epsilon naught? Epsilon naught is 8.54 into 10 raised to minus 12. Since for this mu naught was 4 pi into 10 raised to minus 7, which became, when it came to psi naught, it became 119 into 10 raised to 7 rather. Here, this should also be on the plus side, because this is a big relative world is very big. This is inversing somehow. So it should be something like 10 raised to 12, not minus 12. This as far as this part is concerned, I am doubtful. I am doubtful whether this 8.854 should be retained or should be changed to some other value. That I am not very sure. So the equation, basically the last equation will be into G, not G, L, luminosity, L is equal to uh, xi naught, I am sure, gravitational density plus lambda naught. I am not very sure about this particular value. This I am sure it will be worse. It will be inverse. And then dou G by dou T. It should be in this form, that I am sure. But the only thing I am not sure about is this. That value would change to something else, that I am working on it, and we'll see if we can succeed in getting the value of this. Okay. So as far as this is concerned, we I think we are done here as far as this is concerned. Now we'll go to the second part. Uh, Second part is this is more interesting, in fact, very practical, and you can say it is. If something happens once, we call it a chance, right? If the same thing happens second time, it is with half truth. It can be truth or not. But if same thing happens third time, then it is definitely true. So I always tell you about my chance discovery. My chance discovery rather first was that Planck's constant can be got by multiplying mass of proton 119 times mass of proton and divide by with C. This is 119 into 1.67 to 10 raised to minus 27 to 3 into 10 raised to 8 is equal to 6.62 and 602 into 10 raised to minus 34. That's the Planck's constant. So I told you last in the last this Prasад's constant I called it is equal to same one 11 raised to 4 since this was almost equal to 11 squared. I showed you how I arrived at that. This is a Pascal's triangle 3 into 10 raised to 8. Here it is 11 squared. So for 11 squared, the corresponding this was energy. This I always call the mass or curved side, curved architecture. This is flat or energy architecture. Powers of 10 are energy, powers of 11 are mass and curved architecture. So comparing the similar way, C squared, C cubed, C4. I compared it with the 11 raised to 4 into uh, what do you call mass of sun by C4. I took. What did I get? 11 raised to 4 into 2 into 10 raised to 30 by C4 is 81 into 10 raised to 32. This I got nearly, it was 3.651 or something. Gauss, right? But uh, this 6.51 is neither a constant nor related to any constant. So I got doubt that the next constant should have something to do with some field, some constant that we already know. So what I did was, what I did is I tried with, I tried different combinations, dividing the mass of sun with different constants, different numbers, rather. Then what I surprisingly got was the C4. We are taking C4 for the sun's mass. The constant, Prasад's constant, let us say charge constant is equal to, instead of 11 raised to 4, I took 4 into 11 squared. 4 into 11 squared, when I took, you see, this can be very easily visualized. This is pi r squared, the area of one circle. This whole thing is 4 pi r squared, right? So total surface area. So this constant, instead of taking 11 square, 11 is to 4, I took 4 times 11 square, because if this is the 11 squared corresponds to pi r squared, then 4 pi r squared should be 4 into 11 squared, not 11 raised to 4. So I took this and tried again, that is 2 into 10 raised to 30 by 81 into 10 raised to 32. It came out to exactly 9.81. See, we all know what 9.81 is. It is nothing but g. G equal to acceleration due to gravity. So I did further research and saw why it is so. Why it was so? Because here, instead of 2, we replace it with 2 with 2 is equal to nothing but 119 into 1.67 into 1.67. Instead of 2, you can as well replace 119 into 1.67. What does this become then in formula? As a formula, then this becomes exactly 4. The pi, this thing is 4 into 2 into 10 raised to 30 by 81 into 10 raised to 32. 119 into 1.67 is 2. Yeah, into 10 raised to rather to cancel out the zeros, we need something. So this how many? This is 30. The acceleration due to gravity 32. Yeah, I think they exactly work out to the same. Let us check once again. Uh, 4 into 11 square, 4 into 119 into 1.67 divided by uh, divided by if you take 81, 9.81, yeah, 4 into 119 into 1.67. This 2 figure, let us remove this 2 figure altogether, and this 2 will remove altogether and replace it with 1.67, 119 into 1.67. Okay, 119 into 1.67 gives you 2. I mean, let's say 119 into 1.67 gives you 2. 2 in the sense 200, let's say. Not 2, 200. So 4 times 200 into 10 raised to 30 by 81 into 10 raised to 32, which is nothing but C4. If you take this, it comes exactly to 9.81, which is nothing but acceleration due to gravity. So there is your proof. The third time we were very, I may be lucky. I admit I may be lucky. First time it was Planck's constant. Planck's constant. It's equal to 119 by C, 119 m by C. First one. Second one, I got gravitational constant. Gravitational constant is equal to 1 by 4 into 5 into 119 into 10 raised to 7. First time around, second time around, and the third time around, G is equal to 4 into 119 into 1.67 into 10 raised to 30 by 81 into 10 raised to 32. This exactly worked out to be 9.8. This is the third time around. So, as usual, I rest my case. Well, you may call me, you may call me Mr. 119. If you want to call me Mr. 119, I don't have any objection. I am Mr. 119. Well, I'm kidding. And just what I mean to say is, uh, 119 is very critical uh, number, which is which forms basically the basis of all the constants, all of the important constants. It forms the basis of. So, what is 119? What is 119? I will explain in the next. Okay. Let us call a day for now. Call it a day now, and then we will learn about 119. What 119 is, in fact, and what could be the structure of um, the basic fundamental uh, objects. Fundamental objects have definite geometry, and about the geometry and the importance of number 119, we will learn in the next video. Okay. For now, remember that 119 is the basis of the whole quantum. It relates quantum as well as it is universal. 119, the number 119 is universal. It applies both to quantum as well as relative domains. So, let us wait some other time, in a week or so. Uh, let's call it a day for now. Thank you very much for watching my video. Please subscribe if you like my videos. Thank you.